All right, so again, this is page 3 of our notes. So our x-intercepts, we do have 3 of them. So there's one x-intercept here, another one here, and another one there. So those are all correct. Y-intercepts where it's crossing our y-axis, which is 0, -2, that is there, so those are good. Remember, where positive is where it is above the x-axis. Okay, so there are two different intervals where it's above the x-axis. That's from x values of -infinity to -2, and then also again in this upside down part of the u where it goes from 1 to 2. The negative is where it's below the x-axis. We have 2 spots where that is below the x-axis, so it is this first part that goes here. Okay, so that's from x values of -2 to 1. And then again at the very end, it goes from x values of 2 to infinity where it is negative. So that looks good. We do have a maximum right here that's at 1.54. And is that a relative max or an absolute max? That's a relative. So you might just want to make a note that that is relative. We do have one minimum right here, which is -1.5, comma -8. And again, that is relative because it does keep going down. That's why it's relative and not absolute. And then we are increasing in this interval here. Oh no, I didn't want to do that. All right, good. All right. So we're increasing in this interval here that is green. So that's from x values of -1.5 to positive 1.5. Now, we are decreasing in 2 different intervals. So we are decreasing in this first part that I made red. All right, Tristan? So this part that's red is decreasing. So what x value would this technically be starting at? There's an arrow going to the left. -2 is here, but it's going to keep going to the left. So it's all right. So we'd have to start our decreasing at -infinity. It stops decreasing right here, which is our x value -1.5. And then we do increase it, sorry, we decrease again here at this end part. So we're decreasing from here to here. So what are we decreasing? What x value is this one at? So there's 0. This is about 1.5. And that would decrease for 2. How far right? Positive infinity. Good. And then our domain, it has arrows on both ends. So it's going left forever, right forever, -infinity to positive infinity. And the range, -infinity to positive infinity also. All right, so as we answer these questions at the bottom, it says what occurs between positive and negative intervals. So as we're going from a positive interval to a negative interval, what was created? Yep. So here is it's positive, and yeah, so it's negative to positive is an x-intercept, and then negative to positive also creates an x-intercept. Very good. So your x-intercepts are created when you go from negative to positive. So if you don't have that for the first one, that's our first answer there. You create x-intercepts when you go from positive to negative or negative to positive. All right, what occurs between the increasing and decreasing intervals? So as we went from decreasing to increasing, what happened as we went from decreasing to increasing? What did we create? That point right there. Minims and max, good. So if you go from increasing to decreasing, it would look something like that, increase and decrease, so that creates a max. And if it goes from decreasing to increasing, that would look something like this, that creates a minimum. Then our last part says suppose that a function f whose graph is continuous from a to c is increasing from a to b and decreasing from b to c. Define, and it's defined at b. Describe what occurs at x equals b, and what does the function value f of b represent. So we have our x-axis here. We know that our graph is continuous from a to c, and it says it's increasing from a to some value of b, and then it decreases from x values of b to c. So it's going to look something like that. So what's occurring when x equals b? The maximum. So we have a maximum at the ordered pair b, because b is our x value, and our output would be f of b then. All right, do we have questions from last night's homework at all? Just be careful with number 2. Okay, if you want to take a quick look at number 2 from last night's homework. The positive gets some people, because at -3 and at 3, those y values are 0, which is not positive or negative. So you're going to have to write your positive interval as 3 separate intervals. So from -infinity to -3, and then from 3 to 3 is positive, and then 3 to infinity. By us writing it this way, it excludes the -3 and it excludes the +3, because at those x values, those y values are 0, and we know 0 is not positive or negative. And then, is there any place where it's negative? Good. Yeah. All right, I got you. Thanks. Are there any values where we're negative? Nope, so that'd be none. All right, any questions on last night's homework then? Anything else? All right, then we're going to go to the last page. So Joe, we're on the last page of the blue sheet, blue packet. So we're working on sketches. All right, so it says sketch a graph where it'd be increasing from -infinity to -2 and then decrease from -2 to infinity. So you're looking at, remember, these are x values. So you're looking at any numbers that are overlapping. So if you notice, I have a -2 and a -2, and those are x values. X equals -2. So what I always like to do is I like to draw like a guideline at x equals -2. Remember, the equation x equals -2 is a vertical line. Okay? So I know your graphs aren't very clear on yours, so just go over 2 blocks, label it -2, and then draw a vertical dotted line. Because that vertical dotted line is going to be where our graph is going from increasing to decreasing. Okay, so that those dotted lines represent changing of our increasing or decreasing. So in this particular case, we have to increase from -infinity to -2, and then we decrease from -2 to infinity. So it's going to look something like that. Could I do this? That work? Yeah. It doesn't matter how high up the y values are. It just matters that I'm increasing before the left, to the left of that dotted line, and decreasing to the right of that dotted line. Okay? So any of those would work. So again, what I would recommend is as you're going through these and trying these other two on your own, look to see what x values are overlapping. draw vertical dotted lines at those x values, and then figure out in this first interval, are we increasing or decreasing? In this interval, are we increasing or decreasing? And go from there. What? All right, so again, you're always looking for x values that are overlapping. So we have first x value overlapping is -5. So you want to draw a vertical dotted line going through -5. And again, your graph wasn't the greatest, so just label a -5. The other overlap is at 4. So at x equals 4, we also want to draw a vertical dotted line. All right, so then it says it's increasing from -5 to 4. So in this area, from -5 to 4, we have to be increasing. From -infinity to -5, we have to be decreasing. And from 4 to infinity, we have to be decreasing. It does not matter how high up or down the y-axis we're going. All it matters is that this first part, we're decreasing. So I'm going to start on the left and come down. My graph is decreasing that entire way. I do want to put an arrow on the left because it is saying from -infinity. Then I have to increase this whole next interval. So I have to make sure my graph is continually going up. And then when I get to the 4, my graph has to go down for the rest of the way. No. And then it says what should occur at -5. So at -5, what are we creating here? Relative min, or just in general, a min. And at 4, we created a max. All right, and then our next one, our overlap was at 4. And so we have to go through 0, 0 as well, and it's increasing to start from -infinity to 4. So I'm decreasing and then increasing after that. Is there any way that 0, 0 could be the only x-intercept if we have to increase this rest of this way? No. So there's no way. You have to have two x-intercepts to follow what that is.